Hello everyone. In this lecture I shall discuss the LU decomposition method or matrix factorization method or what we call the Crout's triangularization method to solve a system of linear equations. For simplicity I am considering here 3x3 system, means 3 variables and 3 equations. However, it can be extended to n cross n system. Here it should be a square matrix, okay. So M should be equal to n, right. It can be extended to a n cross n system, square matrix. It should be a square matrix, right. So now considering a system of 3 linear equations here, and in matrix form we write it Ax is equal to b. Now in triangularization method, what we have to do, we have to express this A as the product of L into U, right. A is the product of L into U. What is your L? L is a lower triangular matrix, right. We write 1 0 0, we write L 2 1 1 0, L 3 1 1 1, L 3 2, you write L 3 2 and it is your 1. It is a lower triangular matrix, okay. And you write here upper triangular matrix. U is here U 1 1 0 0, you write U11, U12, U12, U13, and here 0, U21, U23, then 0, 0, U33, right. This is L into U, right. Every square matrix A can be expressed as your L into U. A can be expressed as L into U, provided the principal minors are non-singular. I will write the principle later on. And also in few cases we may write here 1 in the diagonal places of U, and accordingly we fill here L11, L22, L23, L33 we may write here, and you may write 1 1 1 here in case of this, right. In any way you can choose L into U. I choose like this. Now this here A is replaced by LU, then here X is equal to here B. Now this U into X, okay, let it be my equation 1, Now this U into X, let I write it Y, okay. I put U into X is equal to your Y. Let it be my equation number 2. Now with this, what we are getting? So now what will happen with this? It becomes my Ly is equal to B. Now it is a system like this, Ax is equal to B. Can I not simplify to get the value of Y? I get the value of Y as Y1, Y2, Y3, right. I get this now Y1, Y2, Y3 are the constant numbers I am getting. Let I call it my B star, okay. Now I substitute in equation number 2. From equation 2 what I am getting? Ux is equal to my B star. Y is my B star. Now can I not simplify it now? Like your Gauss elimination technique, the last step, just the substitution here. So X is equal to I am getting X1, X2, X3. Okay, this is the working rule. Now this is my answer. Okay. So now before the details of the discussion, let me to introduce myself. Professor Susanta Kumar Paikray, S.K. Paikray, currently working as a professor of mathematics at Surendra University of Technology, in short Visut, Burla, Sambalpur, Odisha, India. So without much delay, let me to discuss the principle on which this A is equal to LU rests, and subsequently let us solve one example to make your idea clear. So now the LU decomposition is based on the principle that every square matrix A can be expressed as the product of a lower triangular matrix as well as an upper triangular matrix, provided every principal minor of A is non-singular. is non-singular. That means that is here the principal minor here. Okay, my matrix A is what? A11, A12, A13, A21, A22, A23, A31, A32, A33. So this determinant, it itself, this matrix, the determinant of this matrix should be not equal to 0. Now if I think of the second order principal minor, I take the principal elements, the diagonal elements fix, take a 2 cross 2 matrix. It is my A11, A12, A21, A22. This determinant should be not equal to 0, right? Not equal to 0. And if I take a single one, this is my A11, this my A11 is not equal to 0, right? So we have collectively A11 is not equal to 0, this is not equal to 0, and this is not equal to 0. So these are three principal minors exist for a 3 cross 3 matrix. So this is not equal to 0. That means the matrix is non-singular. A square matrix A is said to be non-singular if the determinant of the matrix is not equal to 0, right? Once any of the principal minor is 0, then this LU decomposition will not work. So for LU decomposition method, it is necessary that number of equations should be same as the number of unknowns. And similarly for your Gauss-Jordan elimination, it should be also a square matrix, because we need to bring it to a diagonal matrix. But for Gauss elimination method, square matrix is not necessary. Okay. Accordingly, the case may be your unique or no solution or infinitely many solution. For details, you can refer to my lecture series on linear algebra. Okay. So now let us discuss the working rule for this method. The working rule, in fact, I have told that this is the working rule. Okay. In fact, this is my working rule. This is my working rule. This is the working rule. Now let us solve an example. Means first we write A as the product of L into U. I substitute this Ux is equal to Y. Now I solve this Ux is now this. I substitute it here. Now it is Ly is equal to B. I solve it. Okay, I solve it to get the value of Y. Then I substitute it here and I solve again Ux is equal to Y. Right, this B star means my Y. So I solve it to get this answer. So let us consider an example, then your idea will clear. Now you are asked to solve one example to solve the system of equation by LU decomposition method. This method is also known as matrix factorization method or Crout's triangularization method. In fact, I consider the same example as I did in Gauss elimination and Gauss-Jordan elimination to see the complexity of the calculation in each case. So now coming to the solution. In matrix form we write the system of equation. The system of equation can be written in matrix form as follows. 3 2 7 2 3 1 3 4 1. This into XYZ is here 4 5 7. Right. So now this implies, in short, we have AX is equal to B. Now you see this A here, the principal minor, this is not equal to 0, and if I take this determinant, this is also not equal to 0. If I take the entire determinant, this is also not equal to 0. Clearly A is a non-singular matrix. Clearly A is a square matrix, and all principal minors are non-singular. So we use, your LU decomposition method works. Okay, so LU decomposition method works. Let L into U is equal to your A. So I write L. So that means here 1 0 0 L21 1 L21, this diagonal should be 1 1 0 L31 L321. This into U is my U11 U12 U13 U, then it is my 0, this is my 0, and it is U22 U23 0 0 U33. Okay, you see this is a lower triangular matrix, this is a lower triangular matrix, this is a upper triangular matrix. We may write the diagonal element 1 in any one of these two. Okay, so now this is equal to my, what is my A here? A is my 327 327 231 and it is 341. So we find the matrix product in the left hand side. I find the matrix product here, matrix product. So now this first row with the corresponding first column here, it will be multiplied. So this is U11 U11 here, then this will be multiplied here, it is U12 it is U12, then this will be multiplied here, it is here U13, then the second row similarly multiplied throughout, it is my L21 into U11 L21 into U11, then this is multiplied with this, it is U, so this will be multiplied with this second column here, L21 U12 plus U22, then this is multiplied with the third column here, L31 U13 plus L32 U23 plus U33. Okay, then coming to the last, we have this is multiplied with the first column, it will give you L31 U11, and now this will be multiplied with this second column, so it is here L31 U12 plus L32 U22, then the last, this third row with third column, it will give you L31 U13 plus L32 U23 plus U33. Okay, U33, this determinant, this matrix is same as your matrix A, 327 231 341. Now these two matrices are equal, means the corresponding positions are same, right? This position is same as this position is same as this position, and this position is same as this position, accordingly all the places. Okay, so now I first compare the first row, right, to compute your first row of your U. So now systematically I compute as follows. Now we compute the first row of U, for which we compare row 1 with row 1. Okay, so here U11 becomes here, U11 is same thing as 3, then here U12 is same thing as here 2, and here U13 is same thing as here 7, right? This is here 7. So then you compute your first column of your L, then you compute first column of your L, first column of L. So how to compute it? First column of L means we compare this, right? We compare this first column, we compare this first column with this first column. Already this place is done, So we compare this, means this calculation will be my L21 U11 is equal to 2. Already U11 is my 3, so that means my L21 is my 2 by 3. And similarly here L31 into U11, this place is equal to 3. I substitute the value of U1, so that means my L31 is my 3 by 3 is equal to 1. Okay, right? So I compute this. So I compute the first column of your L. This and this are computed. Now coming to the second row of U. Second row of U. Right, second row of U. For second row we need U22 and U23, for which you compute this. Now you compare this, right, with this. Compare this with this. Okay, you compare this with this. So now comparing this with this, what I am getting? L21 U12 plus U22 is my 3, and my this is my 1, and my L31 U13 plus L32 U23 plus U33 is equal to here 1. Okay, now you solve it. Here L21 is 2 by 3 and U22, so for which you substitute L21 here and here U12 here you substitute here, right? So this implies what we are getting, L21 is here 2 by 3 into U12, U is here 2 plus U22 is equal to 3. So that means my U22 is equal to 5 by 3. Then I solve it, right? I substitute L31 here, L1 U13 here, and my L32. Actually there is a calculation mistake here. So this is my second row, third column, 2 3 means second row, third column correspondingly multiplied here. So this will give you L21 L21. Okay, this will give you L21 U13 plus U23. There is a mistake, calculation mistake here. So now this is my L21 U13, right? L21 U13. So now I substitute this value. L21 is my 2 by 3, so this implies my 2 by 3 into U13. U13 is my 7 plus U23 is equal to my 1. So my U23 is equal to minus 11 by 3. Okay, you compute this. Next you compute second row of L, right? Next you compute second row of L, second column of L. For second column of L we have to compute second column of L. So we have to compute this. Now we have to compute this with my this, right? We have to compute this with my this. So we have here L31 U12 plus L32 U22, right, is equal to here 4. So now you substitute the value. L31 is here 1, so 1 into U12 is here 2 plus U22 is here 5 by 3, L32 into 5 by 3 is equal to here 4. So that means you simplify for your L33. So here L32 will be 6 by 5. Okay, 6 by 5. Next you compute here third row of U. So it's only we have my this place to compare with my this step. So what I am getting is here L31 U13 U13 plus L32 U23 plus U33 and this position is here 1. Now you substitute the previous value. So that means L31 is here 1 into here 7 plus it is here 6 by 5 into minus 11 by 3 plus U33 is equal to 1. So that means you simplify, U33 will be equal to minus 8 by 5. Okay, so we get it. Next, adopting this procedure, here AX is equal to B, this procedure we adopt now. Now next my AX is equal to B. So now for AX is equal to B implies here L into U, X is equal to B. Now putting Ux is equal to Y. Let U into X is equal to Y. Right, so substituting this, so that means my here Ly is equal to B. So I have my L, I substitute the value of L here, it is 1 0 0. L21, the value of L21 is 2 by 3. L21 we calculated 2 by 3. Then my it is here 1, it is here 0. Then L31 I write, L31, L32 is my 6 by 5 and it is my 1, and Y is my Y1, Y2, Y3, and what is here B given? B is equal to given here 4 5 7. So now you compare it. Okay, now you compare it. This will give you here X and this will give you here Y and this will give you here Z. Okay, so that means my, if I compare it, my X is equal to 4 and my 2 by 3X plus Y, this plus Y is equal to my 5. Substitute the value of X here. So that means my, I write Y1 here. This is my Y1 and this is my Y2. This is my Y1 and this is my Y2. So that means my Y2 is my 7 by 3. Then I compute here, it is my Y1 plus 6 by 5, Y2 plus Y3 is equal to 7. Substituting the value of Y1 and Y2, I am getting my Y3 is equal to 1 by 5. So therefore my Y1 is 4, Y2 is 7 by 3 and Y3 is my 1 by 5. Okay, so with this Y I now substitute it here. Okay, I now substitute it here. Let it be my equation star. Now from equation star, here U into X is equal to here Y. Y is here 4, we get it 4, 7 by 3 and my 1 by 5. Right, 1 by 5. So what is my U now? U is my U11, it means 1. U11 we got it 3. U11 we got it 3. So this is my 3. U11, U12, U13 it is 2, it is my 7, then 0, then U22 is my 5 by 3, U23 is my minus 11 by 3 and it is 0 0. U33 is my minus 8 by 5 and my X is here X, Y and Z I have taken. Okay, or X1, X2, X3 what you call. So it is my 4, 7 by 3, 1 by 5. Okay, now you compute the back substitution technique here. Back substitution. So here this is equal to this, minus 8 by 5 Z is equal to 1 by 5 and here this is equal to this 5 by 4y minus 11 by 3z is 7 by 3. Then coming to the first row, here 3x plus 2y plus 7z is 1 by 5. So now substituting the value of z here. So that means what is my z? Z is my minus 1 by 8. Minus 1 by 8, I substitute the value of z here. So substituting z, what is your y? Implies your y is equal to 9 by 8, and substituting the value of y and the value of z, I am getting here x is equal to 7 by 8. Okay, so therefore here x is equal to, or y, x is equal to 7 by 8, y is equal to 9 by 8, or z is equal to minus 1 by 8. Or if I write x1 is equal to 7 by 8, or I can write it x2 is equal to 9 by 8 and x3 is equal to minus 1 by 8. If in the question I write it x1, x2, x3, right? If in the question I write it x1, x2, x3, this is my x1. If I write it is x1, x2, and I write x3, okay, as I did in the previous example. So this is what the LU decomposition. Now coming to some remark. Now coming to the concluding remark. As we discussed earlier, Gauss elimination method is less expensive than your Gauss-Jordan elimination method, because Gauss-Jordan elimination method though gives direct solution, but it is lengthy. So in comparison to these two methods, Gauss elimination method is better. However, among all the direct methods, this LU decomposition method is very much used because it is less expensive. Okay, particularly while we fit it in computer programming, then it is less expensive and minimum steps needed. Suppose we work with 10 variables, then Gauss elimination method, the number of steps required in Gauss elimination method is 3 times the number of steps required in LU decomposition method. Okay, so among direct methods, this LU decomposition method is the best one. Okay, but for little number of variables, minimum number of variables, your Gauss elimination is fine, but as the students of engineering or for higher mathematics, we need to work with many variables. So in that point perspectives, the LU decomposition method is better. Okay, so at this stage I should conclude. Now if you feel this lecture is interesting and helpful, please like and subscribe to this channel, which will boost my motivation to upload the subsequent lectures. In my upcoming lectures, I will discuss the iterative scheme, iterative methods, like here Gauss Seidel method and Gauss-Jacobi method, Gauss-Jacobi and Seidel methods, iteration method. Okay, so basically for large variables, large number of variables, these methods are fine, these iterative methods are fine. Okay, moreover where the direct method will not work and these methods are used. So now we should close the lecture here. So thank you all, have a nice day.